Hello everyone and welcome back to GitOps series. In this episode, we are going to learn how to manage Helm application with Argo CD. We will see how Argo CD works with Helm chart, how we can configure Helm values, how to override those values and how to upgrade a Helm application. We will also look at how all of this fits into our GitOps workflow. So let's get started. So why do we want to use Helm with Argo CD? A Kubernetes application can have many resources such as deployment, services, and config maps. Managing all these YAML files separately can become difficult. Helm helps by packaging these resources into a reusable chart. Helm also gives us a values that we can use to change things like image, number of replicas, or service settings without changing the chart itself. Now, when we use Argo CD with Helm, Argo CD manages the Helm application as a part of our GitOps workflow. This means we can use the same Helm chart for different environments such as deployment, staging, and production with different configuration values. So in simple terms, Helm helps us package and configure the application while Argo CD manage its desired state and keep it in sync with the Kubernetes cluster. Now let's look at the overall flow of a Helm application with Argo CD. We start with a Helm chart source. This can be a Git repository or a Helm repository. The source provides the Helm chart that Argo CD will use for the application. Argo CD then works with the chart and its configuration values. Helm renders the chart into Kubernetes manifest, which are the resources Kubernetes will actually deploy. Argo CD then manages those resources in the Kubernetes cluster according to the desired state. So the basic flow you can see on the screen. From chart source to Helm chart and then Argo CD, then Helm rendering, then Kubernetes manifest and finally the Kubernetes cluster. Now let's look at how Argo CD actually renders a Helm chart. First, Argo CD retrieves the Helm chart from the configured source. This can be a Git repository or a Helm repository. It then combines the chart templates with the configured values and any overrides. Helm renders those templates and provide a normal Kubernetes manifest. Argo CD uses these rendered manifest as the desired state and compare them with the resource running in the cluster. If a sync is triggered, Argo CD applies the desired state to a cluster. The important point here is that Argo CD uses the Helm to render the chart. It is not managing the traditional Helm release with Helm install or Helm upgrades. Argo CD manages the resulting Kubernetes resources as a part of GitOps workflow. Now let's look at where Argo CD can get a Helm chart from. There are two common options. The first one is Git repository. Here the Helm chart is stored in Git along with its configuration. This gives us a version control for the chart and its values. This is a good choice when we create and maintain our own Helm chart. The second option is Helm repository. Here the chart is already published and Argo CD can download a specific chart version. This is useful when we use third-party chart or chart maintained by another team. In both cases, Argo CD can use the Helm chart as the application source. The main difference is where the chart is stored and who maintained it. Now let's look at the basic structure of Helm chart. A typical chart has three main parts. First, Chart.yaml contains the chart metadata such as chart name, version, app version, and dependency. Next, we have values.yaml. This file contains the default configuration values used by the template. We can override these values when deploying the chart. And finally, the templates directory contains the Kubernetes resources template such as deployment, service, and config map. Helm takes this template and combines them with the values to generate the final Kubernetes YAML files. Before committing the changes, we can use Helm template to preview the generated output and Helm lint command to check the chart for common issues. Now let's look at a values.yaml in the little more detail, the values.yaml file contains the default configuration for our Helm chart. For example, we can define the replica count, container image, service settings, and resource limits. These values are then used by the templates. Inside our Helm templates, we can access these values using reference like .values.x. This keeps our templates reusable because we can change the configuration in values.yaml file without changing the Kubernetes template themselves. For example, here we can have the replica count set to 2, the NGINX image and the service type set to cluster IP. Once we edit the values, we can commit the changes and let the Argo CD sync the application. Now let's look at how Helm values can be overridden. The base configuration comes from the charts values.yaml file. We can then provide additional values for different environments such as deployment or production. These additional values can extend or override the default configuration. Finally, Argo CD can provide explicit values or parameters in the application spec. These can override the values defined earlier. The final result is the rendered Kubernetes manifest that Argo CD applies to the cluster. On the right side, we have some common example like changing the replica count, image tag, service type, or application settings. The main idea is simple. Higher priority values can override lower priority values. Now let's look at Helm parameters in Argo CD. Parameters are used when we need to provide explicit values overrides in Argo CD application. For example, here we set a replica count to 3. The same values can also be passed from the Helm CLI using --set replica count equals to 3. We can also override other values such as image tag. Parameters are useful when we need small configuration changes without changing the main values.yaml files. The important point is that these values are defined in Argo CD application configuration and become part of the final rendered configuration. Now let's compare value files and Helm parameters. First, values.yaml is commonly used for default chart values and environment specific configuration. These files are usually stored in Git along with the chart or configuration. Helm parameters are useful when we need a small, explicit overrides directly in Argo CD application configuration. For example, we can use a parameter to change a replica count or image tag without changing the values file. As a general rule, prefer values files for regular configuration and use parameters when you need a specific or explicit overrides. Now let's compare Helm with a plain Kubernetes YAML. With plain Kubernetes YAML, what you write is what gets applied to the cluster. It's simple and easy to inspect, which makes it a good choice for simple application and a small number of environments. The downside is that when we have a multiple environments, we may need to maintain separate YAML variations. Helm takes a different approach. It uses the templates to generate the Kubernetes manifest from a chart. With values.yaml, we can reuse the same templates and provides the different values for different environments. So when should we use each one? Use plain YAML when the application is simple and the environment are limited. Use Helm when we need templating, reuse, or configuration that changes across environments. Now let's see how we can upgrade a Helm application with Argo CD. There are two common cases: changing the Helm charts version and changing the application configuration. For a chart upgrade, we update the Helm chart version in the Argo CD application configuration. Argo CD then renders the application again using the new chart version. For a configuration change, we update the values. Argo CD uses the new values to generate the updated Kubernetes manifest. Once the desired state change, Argo CD can synchronize the updated resources with the cluster. So the basic process is simple: change the chart or configuration, render the updated manifest and synchronize the application. Now let's put everything together and look at the complete Helm and GitOps workflow. A change starts with a Helm chart or its value. When Git is used as a source, the change is committed to the Git repository. Argo CD detects the updated desired state and renders the Helm chart to generate the Kubernetes manifest. Argo CD then synchronizes those manifests with the Kubernetes cluster. This gives us a clear flow from the desired configuration to a running application. And if the live resources are changed outside the GitOps workflow, Argo CD can detect the difference and with self-healing enabled, restore the desired state. Now let's go through some best practice when using Helm with Argo CD. First, when using Git as a chart source, keep your Helm charts and configuration in Git. This gives us a clear history of what changed. Next, pin your chart version instead of always using the latest version. This gives us more control over upgrades. Keep values under version control as well and review them just like application code. Avoid using too many parameters overrides. Keep them small and use them only when needed. For different environments, keep environment specific configurations separate, such as values-dev.yaml and values-prod.yaml. Review charts and values changes before they are applied. For secrets, don't store plain text sensitive data in Git. Use tools such as sealed secret or a external secret store. Before deploying, test the rendered manifest with Helm template. And finally, avoid making manual changes directly to resources managed by Argo CD. Make the change in Git and let Argo CD keep the cluster in sync. Now let's move into a hands-on demo and deploy a Helm application with Argo CD. First, we select the Helm chart and create Argo CD application. Here we provide the Git repository and chart path and the revision. Next, we configure the Helm values that will be used for the application. After that, we deploy the application and synchronize it with the cluster. We can also override a values such as changing the replica count to 5 and then let Argo CD sync the change. Next, we can upgrade the application by updating the Helm chart version or the application configuration. Argo CD detects the change, render the Helm chart again and applies the updated manifest. Finally, we verify the updated resources and make sure the application is running as expected. So let's switch to the terminal and get started. Let's create a new Helm chart for our NGINX application. We will use Helm create command to generate the standard chart structure such as chart.yaml, values.yaml and the template folder. We will leave the extra default templates as they are for this demo. GitOps. I will create a directory called as episode 6 CD Helm episode 6 Helm run Helm create NGINX demo. Let's verify NGINX demo. If tree is not installed, you can check with find NGINX demo. You can give max depth 2 and provide the type as a file. The chart already has values.yaml with defaults. We only need to change what's relevant for this demo. NGINX. Now let's open the value file. Values.yaml. Here we will update the replica count to 2. Image is NGINX. Pull policy. We will provide the tags 1.27. Leave everything else as default. Save the file. Later in this demo, we will use Argo CD to override the replica count and change the application configuration. Now let's validate the Helm chart before we continue. We can use Helm lint to check the chart for a common issue. Helm lint dot. This is the expected output. There is 0 chart field. 1 chart is linted. Before deploying anything, let's see what Kubernetes manifest Helm will generate. Helm template renders the chart locally. Nothing touches the cluster. Helm template NGINX demo dot template spelling. There was a typo. This is the correct command. Helm template NGINX demo space dot. Here we can see that the Helm has rendered the chart into normal Kubernetes manifest. We have a resource such as service account, service, deployment, and the test pod. Notice that the replica count value of 2 has been applied to the deployment and container image is NGINX 1.27. This renders the manifest are what Argo CD will manage when we deploy this Helm application. The chart is ready, so let's add it to our Git repository. This is the important part. Git now holds the desired configuration that Argo CD will read from. Let's verify once. Episode 6, enter. Okay. You should see this output. Check the Git status. Okay, let's add the chart. Git add episode Helm NGINX demo. Git commit -m add NGINX Helm chart. Git push. Git status. Your branch is up to date. Okay. Now that our Helm chart is available in Git, we need to tell Argo CD where the chart is and how it should be deployed. We will do this by creating an Argo CD application manifest. This application will point to our Git repository, Helm chart path, and the Kubernetes namespace where we want to deploy the application. We will also configure Argo CD to use Helm for rendering the chart. Episode 6. Let's create a directory mkdir -p. I will create directory in episode 6. Here I will create Argo CD. You can verify episode 6. We created Argo CD as a directory. Earlier we created Helm directory. Let's go to Argo CD. Argo CD directory. Here we will create an application vim nginx -demo -app.yaml. I have the small code. We'll paste it here. Save. Let's verify. nginx -demo -app.yaml. The metadata session gives our Argo CD application the name nginx demo and creates the application in Argo CD namespace. Under the source, we specify our Git repository, the main branch, and the exact path where our Helm chart is stored. Under destination, we tell Argo CD to deploy the application to our Kubernetes cluster and into the demo namespace. Now commit the application manifest. Git status, git add episode Argo CD NGINX.yaml, git commit -m Argo CD application for NGINX Helm chart, git push. Git status, branch is up to date. Okay. Now apply the application manifest to Argo CD. kubectl apply -f episode 6 Argo CD NGINX.yaml, enter. application.argoproj.io/nginx-demo created. kubectl get app-n Argo CD. Sync status is out of sync and health status is missing. It's out of sync and missing because Argo CD has registered the application and detected the 3 resources from our chart: service, service account, deployment, but has not deployed them yet. We will sync it next. Now that Argo CD application has been created, let's synchronize it. During the sync, Argo CD will use the Helm chart from Git, render the chart using the values from values.yaml, and apply the generated Kubernetes manifest to the cluster. This will create the resources defined by our Helm chart in the demo namespace. Let's sync the application. Argo CD app sync NGINX demo. You should see Argo CD syncing the resource, followed by resource becoming healthy. kubectl get applications -n Argo CD. The status is synced and the health status is healthy. Now check the resources in the demo namespace. kubectl get all -en demo. You should see the deployment, replica set, pods and services. Because we configured replica count 2, you should have 2 NGINX pod running. The pod names and cluster IP will be different in your environment. Let's verify the Helm chart values. Run this command. You should see values similar to replica count 2, repository NGINX, tag 1.27. Your exact output depends on the current values which is mentioned in values.yaml file. Now let's verify the deployment. kubectl get deployment nginx-demo -n demo. Then you can check kubectl get pods -n demo -o wide. You should see both NGINX pod in running state. Let's also check this visually in Argo CD UI. Open the Argo CD UI. Here you can see it is synced, healthy, and the resource tree, deployment, service and service account, pods. Same result, just visually. The full resource tree generated from our Helm chart. Now the key feature of this episode: overriding a Helm values through Argo CD instead of editing values.yaml directly. Our chart currently has replica count 2. Let's push it to 5 using the Helm parameters. Go to terminal. kubectl get deployment nginx-demo -n demo. This confirms that we currently have 2 replicas. Add the Helm parameters. Argo CD app set NGINX demo Helm set replica count equals to 5. Our chart currently has 2 replicas. Instead of changing the values.yaml files, we will provide an explicit Helm parameters through the Argo CD application. We changed the replica count from 2 to 5. Now let's verify the rendered configuration. Argo CD app manifests NGINX demo grep -e2 replicas replicas is 5. The desired state now says 5, but nothing changed in the cluster 8. That only happens on sync. Now let's synchronize the application. Argo CD app sync NGINX demo. You should also see the application complete successfully. Let's verify the deployment. kubectl get deployment NGINX demo -n demo. You should now see 5 NGINX pod running. Let's verify Argo CD status. Argo CD app get NGINX demo. The sync status is synced and health status is healthy. 5 replicas applied without touching values.yaml file. That's the Helm parameter overrides in action. Now let's do a real upgrades. Change the NGINX image tag in Git and let Argo CD picks it up. Vim episode 6 Helm NGINX demo and values.yaml. Here we will change 1.27 to 1.27 1.28. Save the file. We can also verify grep tag. It's 1.28. Okay. Commit and push the change. Git add episode 6 Helm NGINX demo values.yaml. Git commit -m update NGINX image. Git push. Argo CD app get NGINX demo. The sync policy is set to manual. This show out of sync once Argo CD detects the new Git revision. Let me refresh the application in Argo CD UI. Let me click on refresh. Here you can see it's out of sync and we have 5 replicas. Go to terminal. Run Argo CD app sync NGINX demo. Sync is done. Let's verify. Now you can see NGINX 1.28 as an image tag. Since sync policy is manual, this shows out of sync once Argo CD detects the new Git revision. Verify the deployment rollout. kubectl rollout status deployment NGINX demo -n demo. The expected output is deployment NGINX demo successfully rollout. Now next step is to verify the updated image. We have already done this verification. We have checked already 1.28. Now let's verify Argo CD app get nginx-demo. The status is synced and health status is healthy. Rollout completes. Image updated to 1.28. Application synced and healthy. Our Helm application has been successfully upgraded through the GitOps workflow. Now let's switch to the slide. Let's quickly recap the key points from this session. Helm packages the Kubernetes application into charts and templates their resources. Argo CD can use the Helm chart as an application source and manage their deployments. Helm renders the template into Kubernetes manifest, while values controls the application configuration. Parameters allow us to provide explicit values overrides when needed. Helm also makes deployment reusable and configurable across different environments. Git maintains the desired configuration, and Argo CD manage the synchronization with the Kubernetes cluster. So in one line, Helm packages and renders, while Argo CD manage and synchronize. That's bring us to the end of this episode on managing Helm application with Argo CD. I hope this session gave you a clear understanding of how Helm and Argo CD works together. If you found this video helpful, please like and share it with your team and subscribe to the TechOps tutorials for more Linux, DevOps and Kubernetes content. In the next episode, we will look at Argo CD image updater and how it can automatically update container image. Thanks for watching and I will see you in the next one.